Okay, today we're going to be doing solving DEs, and we're going to be doing first order and second order DEs. So we'll have a look at these. Okay, so firstly, if we've got the situation where dy by dx is equal to some function of x, okay, dy by function of x, then like we saw in that first video, then what happens is that if we're trying to find the solution to this, then y will be simply the antiderivative of f of x dx. And it's that simple. And that's it. So all we have to do is integrate it, basically. Now, that'll give you the general solution. If you want a particular solution, then you'll need a point. Point. Okay, so some x0, y0, something like that, that you can plug into that to find your variable. Okay. Second order that we're going to look at for today is d squared y on dx squared is equal to some function of x. Okay, so if you've got that situation, then what you need to do is integrate it once, and you get dy by dx is equal to the integral of f of x dx, and then if you integrate it again, you get the solution y equals the integral of f of x dx. I'll just put them in brackets, dx. Okay, so in other words, you're just integrating twice. That'll get you the general solution. If you want a particular solution for this one, have a think about this. In this one, if you integrate it once, you get one constant there. Okay, that's fine. Here, integrating it one time, you get one constant. Then you're integrating it again, you're going to get another constant. So you're going to have two constants that you don't know. So to find the particular solution, you'll need two points. Okay, so you need x1, y1, and x2, y2. 2 points on there to be able to find first constant and the second constant to be able to find your particular solution. Okay, let's crack on. I'm not going to do any difficult integration today because I've covered that. I don't want to take ages doing this. I just want to look at some pretty simple examples just to show you what's going on. Okay, so find the solution to something nice and easy. This one. Something like that. Okay, find the general solution. I'll say given. No, I'll do a general one first. Okay, so find this dE. So therefore, y is equal to be able to solve this, the derivative of y is equal to that. So therefore, y is either the integral of 2x plus 3 cubed dx. Okay. Remember that if you have a linear expression raised to a power, then you can just integrate that straight away. So that's equal to 2x plus 3. You raise the power by 1, 4. You divide by 4. Put that border out the front. And you also need to divide by the 2 in here. So divide by 2, I'll just put half out the front there. Plus c. Okay, so that's equal to, I'll just clean that up a bit, 1/8 2x plus 3 to the power 4 plus c. Okay, so y equals. And that is your general solution. Okay, got the c there, it's a general solution. And we can't find out c, we haven't been given another point. Okay, so I'll do one more example of something like that. Let's find maybe one with a second derivative. Just thumbing through the textbook to find something a bit more interesting. I'll just do something. I'm just going to do something simple. I'm not going to do any technical integration because that's for another time. Here we go. Let's find the solution to this. Okay, another general solution. So therefore, dy dx. So we're going to integrate it once. So this is the second derivative. To get to the first derivative, we want to integrate 5x cubed dx, and that's equal to the x cubed goes to x to 4, and we divide by 4. So 5 fourths x to the 4, and we'll get a plus c. So that's dy by dx. But we're not done yet. We want to know what y is equal to. So to find y, we need to integrate again. So we'll integrate 5 on 4x4 plus c dx. Right, what is this equal to? Right, the x4 goes to x5, and we divide by 5. So that's 5 quarters, and I'll just put divide by 5 at the end there. Okay, just to keep it clear. You know what's going to happen. So that goes to 5, and you divide by 5. Now that's that part there. We need to integrate c. That's just a constant. So when you integrate a constant, it becomes cx. And then we're also going to have d there, a new constant. You could call it c1 and c2. It doesn't really matter. Whatever you like to call it, cx plus d. I'll just clean that up. That 5 will cancel with that 5, and we're left with 1 quarter x5 plus cx plus d. And that is your general solution. Again, we don't know any points, so we can't find c and d. That's as good as it gets for that one. Okay, let's do some ones where we're given a point. So let's do this. Dy dx equals e to the negative x, and given y0 equals 0. So a nice little initial condition there. Makes it easy when you've got a 0 in there. Okay, so first derivative is equal to that, therefore y, the solution that will be the integral of e to the negative x dx. Okay, what's that equal to? Well, that's just equal to e to the negative x, but we need to divide by negative 1 now, so it'll actually be negative e to the negative x plus c. So there's your general solution there. That's your general solution. But what we can do is we can use this condition here to find out what c is equal to. So y of 0 equals 0. That means that 0 equals negative e to the power 0 plus c. E to the power 0 is 1, and so therefore we'll get negative 1 plus there, so c is equal to 1. Therefore, the general solution, particular solution, y equals negative e to the negative x plus 1. And there's your particular solution. Okay, so that's the general solution, and here's the particular solution. We needed a particular point to find that particular solution. Okay, I'll do one more with the second derivative. One more, just let me find a reasonable one. I'll do this one. D squared y on dx squared is 2 minus sine 2x. And we're given y of 0 equals negative 1. And we're also given y dash of 0 equals half. Just let me check that, just want to get that right, make sure. When x equals 0. Okay, so good. So let's have a look at this. Firstly, let's find the general solution. So let's work through that. Therefore, the second derivative is equal to this, so let's find the first derivative. I fully intended that to be in blue. Dy dx will be equal to the integral of 2 minus sine 2x dx. Right, what's that equal to? Integral of 2? 2x. Integral of sine 2x? Well, sine goes to negative cos, so it will be plus cos 2x, and it's 2x, the derivative, that's 2, so it will be half. Half cos 2x plus c. Fantastic. Now, at this point, look at what we've got. We've got the derivative of y with respect to x is equal to this. And here it's telling us the derivative of y at when x is equal to 0 is equal to half. So we can actually find what c is equal to. We could wait until the final solution to that, but it's better to do it now. So let's use this here right now. So therefore, what we've got, y dashed of 0 equals half, tells us that, what have we got? We've got when x is equal to 0, so we've got 2 times 0 plus half cos of 0 plus c is equal to a half. Fantastic. 2 times 0, half cos 0. Cos of 0, that's 1. Therefore, we've got half plus c equals half, which tells us that c is equal to 0. That's a bit boring. Never mind. C is equal to 0. So therefore, we have dy dx is equal to 2x minus plus half cos 2x. C is equal to 0, so that when that comes down to there, c is equal to 0, so it's equal to that. Therefore, I'm going to run out of space. Y is equal to, we want to get to y, so we just need to integrate again. 2x plus half cos 2x dx, and we go across, sorry, equals integral of 2x, x squared. Integral of this, well, cos will go to sine, so it will be plus sine 2x, and we're going to be dividing by 2, so it's going to be 1/4. Plus, let's use a new constant, a new integration constant, d. Fantastic. There we go. And we also know that we've got this point up here, y0 equals -1, so y0 is equal to, let's plug in 0, 0 squared plus 1/4 sine 2 times 0 is 0 plus d, and all of that is equal to -1. -1. Therefore, I'm just going to do it quickly, 0 squared. Sine of 0 is 0, and so that all equals 0 there, so therefore d is equal to -1. Therefore, I'll do it in red. Our general solution is y is equal to x squared plus 1/4 sine 2x, and d is equal to -1, so plus d minus 1. That is your particular solution there. Okay, and that's how to solve those simple d's. They're simple ones. We're going to get to some more complicated ones in a bit.